So I want to take a moment to talk about two different things here. I want to talk about our fish. And what I really want to talk about is how we evolved amphibians. So there's a question on your worksheet that asks you to trace out the pathway from Osteichthyes to our early amphibians. So let's go ahead and do that together. So let's start with our Osteichthyes. So our Osteichthyes are our bony fish. Right? All of our bony fish, these are the ones that you eat, right? If you eat a catfish po' boy for lunch, you're eating an Osteichthyes. Now remember, there are two groups of Osteichthyes. Our first group are Actinopterygians. This is what 2 degrees gets you. You can spell these fancy words. Remember, our Actinopterygians are the ray fin fish. These are most of the fish alive today. So this is your catfish. Our second group is our Sarcopterygians. These are our lobe fin fish. So what's interesting is the difference between here is our ray fin fish. They have very delicate very delicate fins, and they use them to swim. Our Sarcopterygians have very thick, stout fins that they actually use to walk along the bottom of the ocean floor. So if we're going to think about which group here would lead to walking, obviously that would be our Sarcopterygians. So let's take a look at our Sarcopterygians. There are two groups here. The first ones are our Dipnoes. These are cool because they are double breathers. They can breathe both on land and in the water. Now these are pretty cool freshwater lungfish, but these do not lead to the rise of amphibians. What we want to look at is our Crossopterygians. These are also double breathers. Okay. Now, what's really cool about our Crossopterygians, and you're going to see here in what you saw, is that due to pattern of bones in the limbs, pattern of bones in the skull, and their teeth, we see that these are equal to our amphibians. Right? They have very similar patterns there that show us that there's an evolutionary pathway. So we definitely know we want to look at our Crossopterygians. Well, there are two groups of Crossopterygians. Our first is our coelacanths. Now, coelacanths are really cool Crossopterygians. They're still around today, but they pretty much stay in the water. However, we can look at our Rhippidistians. Now, Rhippidistians are neat because these guys, some of them can walk on land. So this is our pathway from our Osteichthyes to our Sarcopterygians to our Crossopterygians, and finally ending up with our Rhippidistians, which eventually lead to amphibians. So I want to talk about why our fish would leave the water for the land. So hopefully you watched those videos there in the previous slide and you actually saw these fish kind of squiggle their way around and walk on land. But let's remember what's going on here geologically. So let's say we have something like this. Hopefully you're recognizing that this is a landlocked basin. That's what I'm about to draw. So here we are in our landlocked basin. Sea level is high, and we've got fish swimming around. Let's say our Sarcopterygians, or our coelacanths, or excuse me, our Rhippidistians. They're swimming around, and life is good. But what's going to happen when sea level lowers? All right, so let's say here our sea level lowers, all right, and sea level now is restricted. We have our landlocked basin. Well, here we have our fish now. They're stuck in the basin. Well, what's going to eventually happen to that water that's in that landlocked basin? Obviously, it's not being replenished by what's going on out in the ocean because there's no connection. So what eventually happens to this water? It evaporates. Now, because it evaporates, what happens to the fish? Right? Well, they would die. So wouldn't it be a fantastic adaptation if these fish could come up onto land and walk their way into the next basin and be happy and be able to swim around. And that's exactly what we see. So we see that these cross-opterygians evolved walking to get to the next basin. And we see this in organisms today, right? As you saw with the walking catfish, right, that we find all over Florida, and that you saw with the snakehead fish. They both walk on land, right? Once their habitat kind of gets low on water, they're able to get up and walk to a much more favorable environment. So that's actually a pretty smart adaptation that keeps the organism alive a heck of a lot longer. So walking fish, that's pretty neat. And we're going to see here in the late Paleozoic that our early amphibians have superfish characteristics, and there's some organisms we're going to see like Osteichthyes that looks like a cross between an amphibian fish.